So let's take a look at this situation right here. Let's say I've taken this charge and I've brought it within the distance of R1 to Q2. As soon as I let go, what's it going to do? It's going to accelerate away. So how on earth can I figure out what its speed is? Well, if we use forces, the problem is the force isn't going to stay constant because we know the acceleration is going to be experienced as force divided by mass. But as this particle m gets further away, the force is going to decrease. So instead, let's take a look at this from an energy perspective. If we look at this initially, we know total energy will remain constant. So initially, particle Q1 has electrostatic energy and kinetic energy. So in this case, we know it's going to be 0, so I'm not going to worry about it. This is just simply going to be K Q1 Q2 over R. In this case, remember, it's going to be a positive value because we're looking at two positives. We eventually let go, and it's still going to have some electrostatic energy, but it's now going to have kinetic energy because we're going to have some unknown speed. So we'll also have here K Q1 Q2 over R prime, we're going to call it, because that's going to be our further distance. And it's also going to have 1/2 mv prime squared. And yet we're going to call it v prime because its initial velocity here was 0. So I think you can see where I'm going with this. We're going to do some rearranging. So I'm going to bring this to the other side, and I'm going to have K Q1 Q2 over R minus K Q1 Q2 over R prime is equal to 1/2 mv squared. So let's do a little bit of rearranging on this. I can see that I'm going to have a K, I'm going to have a Q1, and I'm going to have a Q2. Now, it's a little confusing the way it's written right here. So what I'm going to do is I'm going to propose that we put a negative sign in front here. And now it's looking at your final distance subtracted your initial distance, which is going to be equal to 1/2 mv squared.